Okay, I have a little practice problem for these vector composition and addition problems. To just kind of walk you through how to do this. These are similar to 5.1, 5, 6, 7. You walk 8.1 kilometers at 71 degrees east of north, and then you walk 5.2 kilometers at 25 degrees south of east. What is your displacement, or how far and in what direction did you walk? So in the past, when we just had them going straight east, west, north, south, we could just take these two lines and move them together and just simply make a triangle. But it's much more complicated when we've got these motions that aren't directly north, south, east, west. So what we need to do is to break these lines into their components. So we can see that this guy is going, here's north, right? So he's going from that north piece he's 70 degrees east of north, right? Because this is north going up here. So he's 70 degrees east of north. And then when they turned here, when he turned here, again, if I draw my lines here, that is east. He's moved south 25 degrees. Does that make sense? Hopefully you can see that we're just breaking these into their pieces. So we can make a triangle here, right? That here is my y, and here is my x. And then again, here is my x, and here is my y. So we need to find the values of that x and y. If you don't mind, we're going to give these labels just to make our life a little bit easier. So we're going to call this A, and we know that that equals 8.1 kilometers. And we're going to call this AY, and we're going to call this AX, just simply so that we know what we're dealing with here. We're going to call this guy here B, and we know that B was equal to 5.2, and we'll call this BX, and we'll call this BY. So let's take and deal with A first. So we know that this angle was 70 degrees. We know that A is equal to 8.1 kilometers, and here's AY, and here's AX. So if I want to solve for A, let's start by solving for AX. Well, we know that AX is the opposite of this 70-degree angle. And so sine is opposite over hypotenuse, right? So basically we're saying that sine is equal to AX over A. The hypotenuse on the bottom, A, AX being that x component. If I solve this to get AX by itself, because of course that's what we don't know, I'm simply going to multiply by A on both sides, right? So that therefore AX is equal to A times the sine of theta. Let's plug in our numbers. So AX is equal to 8.1, that's our value of A, that initial number we were given, times the sine of 70 degrees. If I pop that into my calculator, the sine of 70 is 0.93969. I multiply that by 8.1, and so therefore AX is equal to 7.6 kilometers. So what we're saying is that this distance is 7.6 kilometers. That's how far, in this case, is east, because remember, here's our north, south, east, west guy. We are going east 7.6 kilometers. If I want to find out for AY, well, AY is adjacent, and we know that the sine, right? The sine, not the cosine, not the sine, it would be the cosine. The cosine of theta is equal to adjacent over hypotenuse. So what we're saying here is that the cosine of theta is equal to AY over A, right? And if I want to solve this and get ourselves so we just are dealing with AY all by itself, then I can solve this as AY is equal to A times cosine of theta. Because again, I just simply multiplied A on both of these sides to get AY by itself. Let's plug in some numbers. So AY is equal to 8.1, again, the initial vector we were given at the start of the problem, times the cosine of 70 degrees. If I pop that in my calculator, the cosine is 0.34202 times 8.1. So AY is equal to 2.8 kilometers. So therefore, we've gone 2.8 kilometers north and 7.6 kilometers east. That's simply just in my first motion. Does that make sense, my friends? In some of your problems, they give you one of these that have a degree, and the other one is just going just straight east, west, north, south. Well, then we don't have to do the other triangle because it's only moving one direction. But because in this problem we have two different angled motions, we have to now do the same thing that we did for A, we must now do for B. So let's draw our triangle here for B. So we started out here at our origin, and we were going down, and we knew that this angle was 25 degrees. And we said that B was equal to 5.2 kilometers. So here's BX, and here's BY. Now notice, because we are going, if you go back to our instructions here, they're going south of east, right? So therefore, we know that this has got to be negative. We're going in the south direction. So therefore, that y is going to be negative. We'll come back to that when we finish here. So let's find our components again. Let's start off with by. Doesn't matter which one you start. That's just the way I picked it. By is opposite of that 25-degree angle. And again, we know that sine is equal to opposite over hypotenuse. So the sine of theta is equal to the opposite, which of course is by over b. To get this by itself, I multiplied both of those sides by b. So therefore, by is equal to b times sine of theta. Let's pop in some numbers. So by is equal to 5.2. Again, that's my initial amount I was given, multiplied by the sine, multiplied by the sine of 25 degrees. When I pop that in my calculator, the sine of 25 is 0.42261 times 5.2, which gives me by as equal to 2.2 kilometers. So we're saying we've gone south 2.2 kilometers. And now let's see about our x. So x is my adjacent side of this triangle we've created. So therefore, I'm going to use my cosine is adjacent over hypotenuse. And again, cosine of theta is equal to bx all over b. I'm just substituting adjacent for bx and b for hypotenuse. To get bx by itself, I multiply them both by b. So bx is equal to b cosine of theta. Let's pop in some numbers. Bx equals to 5.2. That was my starting point up here, 5.2. Times the cosine of 25 degrees. So I pop that in my calculator. Cosine of 25 degrees. I didn't write down. I apologize. It's going to be a very small number. I multiply it by 5.2, and I'm going to end up that bx is equal to 4.7 kilometers. So we know that I moved east 4.7 kilometers. Okay, so we've done this work so far to take these two triangles, the two vectors we were given, 8.1 kilometers at 70, 5.2 kilometers at 25, and I've broken them into their x's and their y's. Now I'm going to add those guys together because I have now my y and my x for my a, and I have my y and my x for my b. So, because we know that r squared, the resultant of these two motions, is equal to my rx, so both of my x's added together, plus my resultant in the y direction, all my y's added together. And I'm squaring all of those, of course, because it's Pythagorean's theorem. A squared plus b squared is c squared. So, let's do our math here. R squared, I'm going to take and I'm going to add ax plus bx squared plus ay plus by squared. I'm simply going to put the two x's and the two y's that I just found together into this problem. So r squared is equal to my ax, we said, was 7.6. 7.6. My bx was 4.7. And notice both of those are going in the same direction, right? It's going east, right? So they're both positive x's. So we'll add those together. 7.6 excuse me, is being added to 4.7 plus, now for my y's. My ay, this guy was going north, was my y component. So therefore that will be positive. My y is 2.8. So 2.8 was my ay plus my by was 2.2. But notice again, we're going south. It moved south of east, right? So therefore that y has to be in the negative direction. So therefore it will be minus 2.2. And again, the reason why we did that, and that's a very important step, is because when I made my triangle, here is my origin. I'm moving south of that x-axis. So therefore, that must be a negative y that we are doing here. Let's add these guys up. That r is the square root of 12.3 squared plus 0.6 squared. I square them and add them. Excuse me. That r is equal to the square root of 151.65. I perform my square root and I find that r is equal to 12.3 kilometers. So I know that the total distance that I traveled if I went in a straight line from where I started to where I ended, would be 12.3 kilometers. But there's still one more piece I need to do. I need to know in what direction is that going. North? Is it south? Is it east? What is its direction? And we can do that by looking at these two resultants, at the Rx and the Ry. You see my Rx is 12.3, my Ry is 0.6. So if I were to draw this triangle, it would be an X that is very long and a Y that is very short, right? So I would have, if I'm starting here, a long going east and a very short Y that is still positive, so it's still going to go north. Like this. And that's even still too high. It should be a much smaller Y even than that. This is my Rx, this is my Ry. I know it goes north because this 0.6 is positive. I know it goes east because the 12.3 is positive. And this here, that is the resultant that I just found as being equal to 12.3. But what I need to know is, what is that angle? We know that my Rx is 12.3. I'm rounding both. You notice those are the same numbers, right? And I apologize, I just noticed that myself. And again, that's because this 0.6 is so small. So we know that this is 12.3, and we know that this is 0.6. So using that, we're going to use our theta equation. That theta is equal to the inverse tangent of Ry over Rx. We got that because, of course, tangent is opposite over adjacent, and we just solved it out to get theta all by itself by taking the inverse of that tangent. So theta is equal to the inverse tangent of 0.6 divided by 12.3. When I perform that math, I get, oops, I didn't actually put this here on my paper. I apologize. So I'll do it right now on my calculator. 0.6, I divide it by 12.3, and I get 0.048780. I take this inverse tangent of that, and I get 2.79 degrees. What that tells me is this is a very, very small angle, right? Way smaller than what I drew here on the board. And we know that that angle is 2.79 degrees north of east, right? Because here is my east line, and I am moving upward 2.79 degrees north of that east. So the final answer for this thing of how far did we go? 12.3 kilometers, 2.79 degrees north of east. Hopefully you found that helpful.